reactions such as trans-esterification and esterification. This reaction includes the reaction between vegetable oil and animal fats with alcohol such as ethanol and methanol. In most cases, ethanol is used because of its low cost value, but in this case, I choose methanol because of its high conversion rate. In this trans-esterification process, the alcohol is removed by reacting with a base to form a strong nucleophile. As can be seen, there are no other contributors to the reaction than the triglyceride and alcohol. Animal plant fats and oils are composed of triglycerides, and these are the esters formed by the 3 fatty acids and glycerol.
We have made a table here, and then our team, we will decide which catalyst is the best catalyst by 3 criteria. The first criteria is conversion rate, the second criteria is reaction condition, and the third criteria is reaction time. So conversion rate is basically means the percentage of product can be produced from that particular amount of raw material. Then reaction condition meaning that in what condition or temperature the catalyst can give out the effect to the maximum. And then the reaction time means that how much time needed for the catalyst to fully react and to produce the desired amount. So after analyzing the table that we have made it, we suggest that the best solid catalyst for this particular reaction is cesium exchange tungstophophoric acid.
There are totally 9 steps of general procedure to prepare the catalyst. First step is precipitation of gel formation from starting materials. Second step is decantation or filtration to separate the solid phase from the mother liquid. And then is washing step to eliminate the impurities. The fourth step is drying and then crushing and grinding. After that, forming step was carried out to obtain the suitable size particle of catalyst. Next is calcination step, which is a further heat treatment beyond drying. After this, impregnation step was carried out. Final activation is the last step, means that the catalyst activated after done all of the preparing method.
Properties of catalyst is divided into 3, which is chemical properties, physical properties, and morphological properties. For these 3 types of properties, there are specific characteristics techniques that they have. For chemical properties, the first technique is called temperature programmed desorption of ammonia, or NH3 TPD. The second one is temperature programmed desorption of carbon dioxide, CO2 TPD, and the last one is EDX, energy dispersive X-ray. Physical properties, there are 3 characteristic techniques, which is BET, Bronner Emmett Tail, BJH, Barrett Joyner Helenda, and TGA, thermogravimetric analysis. The last properties, which is morphological properties, it has 2 types, which is SEM, scanning electron microscopy, and TEM, transmission electron microscopy.
Part 2, number 1, which is propose a suitable catalytic reactor for the production of biodiesel with a suitable diagram and justify your selection. So based on what we have learned from the previous subjects and all the data infos that we have gathered from the internet, it shows that there are actually 3 general types of reactors that can be used for biodiesel production. The first one is batch reactors, the second one is semi-continuous flow reactors, and the third one is continuous flow reactors. So after analyzing and research, we decided that continuous flow reactor is the most suitable reactor for this particular process. The reason why is because it can result in consistent product quality and low capital and operating costs per unit of product. So to be specific, our team suggests to use microreactor, where it is a mixing device composed with a micron scale flow channel, and it was applied in continuous reactor to control exothermic reaction heat to increase the product yield. And By using this micro mixer reactor, the reaction heat can efficiently remove so that virtually no impurities were produced during the reaction. And then the product yield by using micro mixer reactor, if compared to the theoretical value, is actually very near, which means the humanity error is the lowest, and a product yield comparable to the theoretical value was achieved in just only one single micro mixer unit, which can save a lot of cost for the company.
In this case, the KM micromixer was found to be the best over the other designed for mixing two immiscible fluids. Why? Because it produces the highest throughput and it also produces a stable operation for different flow rate ratios. In this investigation, the KM micromixer was used as a microreactor for the transesterification process of waste vegetable oil with methanol in the presence of sodium hydroxide catalase. The influences of the transesterification process variable, such as the alcohol to oil molar ratio and the volumetric flow rate, the catalyst concentration, were all optimized. GCMS analysis was utilized for characterization and identification of the production of biodiesel.
There are a few significant challenges that faced by Malaysia biodiesel industry. For the first challenge is food and environment debate, means that the increment of palm oil for biodiesel has created a shortage in palm oil supply and need a large area for the oil palm plantation. Malaysia is facing research and development challenges about the palm oil production quantity and quality for shaping Malaysia to become a leading palm oil biodiesel producer. Besides that, the controversial side of genetic modification technology remains as an issue or an challenge for Malaysian government to be handled. Apart from that, Malaysia over dependency on palm oil as the main feedstock for biodiesel production will also be one of the challenges that will certainly drive up the price of the crude palm oil. Last but not least, another challenge to be Malaysia is biodiesel industry will be in terms of garnering sufficient public support and increasing the public awareness on the biodiesel industry.
In 2019, the total biodiesel consumption in Malaysia is about 940 million litres. It increased about 40% compared to the previous years. This is due to Government of Malaysia (GOM) that announced its national biofuel policy in 2006 to cut down the need on fossil fuels and help to sustain the palm oil CPO industry. Biodiesel production in Malaysia increased from 249 metric tons in 2012 to 501 metric tons in 2016, growing at average annual rate of 25.91%. In 2016, the production decreased with negative 25.56% changes. The total biodiesel export in Malaysia in 2019 is up to 750 million litres. It increased about 35% compared to the previous year due to increase in demand by the European Union and China.